Okay, so now we are on the 9th Fusion tutorial, and we'll have two activities in this tutorial, and for our first activity we'll be doing joints and assemblies. So what you want to do if you haven't done so is go to the Google Drive file, and under tutorial resources you can download the step file for I think it was like a plunger or something. But anyways, what I'll do now is with that file downloaded, I'll just go to open. Open for my computer, the hold down clamp over here, hit that. So with this now in Fusion, you can see we have our part and it's all nicely put in the right place, but it's kind of in the wrong way, right? We want this bottom face to be on the bottom plane. So what we'll do is we will just show our origin. We're going to use the move command. I'll use the shortcut M, and I'll just select this edge here. And since it's already on the line, what I can just do is just rotate this. Or I have to select all the components as well. And then I'll just rotate this by 90 degrees. Okay. And now, if there's something that you haven't already noticed, there's something I should do before I start working on this, which is first off, to capture my design history, because you can see I don't have a timeline. So I'll capture my design history. Now I've got my timeline. And what I'll do is I'll just save this. I'll just save it as the hold down clamp. Maybe I'll just type this too. Okay, so now that we have our clamp, what we want to do is basically give it some movement, right? As you can see, if I were to click and hold my handle, it just sort of moves around freely, right? It doesn't actually move in the way that I want it to. Now, again, if you don't know what this part does, don't worry, neither do I, but I do know how it's meant to move. And so what I'll do is, first off, I'll explain a little bit about as-built joints and joints. For as-built joints, it's in the name. It's basically, this is as-built because all the parts are in the right location. If I were to move these away, let's just say that, now these are no longer in the right parts. As you can see, right? They're not located in the right area. So in that case, you'd have to use joints. We'll do this afterwards, but for now, let's just stick with the model we have. So what we'll do is we'll select as-built joint. It's under Assemble, as-built joint. And the first thing we'll do is if you look at it, we want to make this part here sort of static. We don't want this to move because this is going to be the part that's mounted to our table or workbench or whatever. So in this case, what I'll do is I'll select the component. And remember, it has to be components, not bodies. So if you have a part that you've designed, just right-click, create component from bodies. But for now, we have components. So I'll select this flange body component with my as-built joint selected. Then next, what I need to do is tell it what to be rigid to. In this case, you can see here rigid. So I'm going to select the origin. And for some of you, it might preview a motion. If not, it'll look something like this. And this motion just means that it's sort of welded in space, right? So select rigid if you haven't, hit OK. And now think of this as welding a part in space, right? So even if this wasn't flat on the floor, this is right now fixed to this exact coordinate in three-dimensional space in Fusion 360. So if you see I try to move it, I can't. If I click on this handle, I can. And you can weld this, so if say these two pieces were welded together, I would then put a rigid joint between these two. But of course, these aren't rigid, so I'll move on to the next one. What I'll do, oh, by the way, before I forget, all your joints can also be seen here under the browser window. So over here, you can see my rigid joint there. It's also in the timeline. If I ever want to go back and make edits, say I want to change this to something else, I always can. In this case, I don't want to. So, okay, so we'll move on now. What we want to do is to make this lever part here. It's called the bottom clamp. We want to make this rotate around this axis here, if you can see. Right, so this is the pin, this is the lever, it rotates. So how can we do that? Now, same thing, we'll build an as-built joint. We'll select the lever or the clamp, and then we'll select the rigid body here, which is our flange body. Now I can see here it's giving me rigid. I don't want it to be rigid. I want it to actually revolute. In this case, revolve around a point origin. So if you don't quite understand, don't worry, you might once I show you. But select revolute. Now it's going to ask you for a snap. And in this case, what we want is the outer edge here The middle also works, but I'll just select the outer edge. And you can see now that it's going to revolve around this body, like so, around the pin. Again, we can set limits if we want. In this case, we don't, because there's actually some freedom of movement. And also don't worry, because when we do the next part, you'll actually see a cool little feature. But for now, we'll hit OK. And now we have our second joint, the revolute. And what I want you to see also, I've done this before in the past, as I demonstrated it, but you can see how I can click and drag and move these parts around. And if I were to go, just leave it here, you can see again, position, there's revert or capture position. Most times, like 99% of the time, you're going to want to always revert. In this case, I'll just revert. But just take note that if you moved it and then try to do something else, it's going to prompt you to revert or capture. Just always hit revert if you're not sure. And this will return it to the original. But for now, we have our two parts here linked with a joint. So the next thing we want to do is now connect this handle clamp, I'll call it the handle, to the body itself. And again, you can see it's got a pin in the middle there. So we want to use a revolute joint. So I'll again select this component, select as built joint. I'll select this body flange. Again, this is the part that we want it to revolve around. And for the snap, we are again just going to use the edge, inner, outer. I think it doesn't really matter. Yep. But now this time, what we want to do is we want to set a limit, because you see there is actually a little stopper here to prevent you from moving forward down. Now you can always click and, so what you do is you select the tick mark here, minimum, maximum, and you can always drag it up or down however you want. In this case, I know the actual degree, which is 0 and 65. All right, if we hit OK, what we can do now is if we then go and drag this, you can see I can drag it, but the moment I try to pull it down, it stops because of the limits. And so this will simulate sort of like how it would work if it actually did hit this thing. As you can see, it's not perfect, but for visual demonstration, it's more than enough. So now we have our lever, we have our clamp, and we have our handle, and we'll just revert position. And now what we want to do is to actually connect all these three parts with this middle piece here, the inner side. And you can see here this inner side is actually in between all three components. So how will we do that? Well, we know that these two are revolutes, so let's start there. We'll go to as built joint again. We'll select the inner side here, this small little part. And again, revolute is fine. What we want to do now is we'll start with the second rotation at the bottom here. So again, if we check, you can see that, if I'm not wrong, this is connected to the lever itself. Yeah, the bottom clamp. So if we select the first component as our inner side, and then we select the bottom clamp, and now with the revolute, we again select on this edge. You can see this is how it's revolving, that's correct. We'll hit OK. And now we'll do the last one for this part. We'll do as built joint again. Revolute, again select our inner side. And this part is actually connected to the handle clamp. So we'll select the handle clamp. And you can see here that there's, how do you say, there's a, we can't really get an edge. I mean, you could select this, but I want to show you something also. And that is, you can actually select the center point. Because remember, if we can select the center point here, you can also select the center point here. And for me, this is a lot easier to select, so I'll just select here. And you can see it also works in the same way. So think of it as an axis of rotation. Again, we don't want to put any limits for now. And we'll hit OK. And lastly, again, with this, the last joint we want to sort of put for this little assembly on the right side is we want this handle, as you can see, it's come free. We want it to be a part of this lever. So again, we'll just select as built joint. We'll select the grip, the handle, and we'll make this rigid. Hit OK. And now, if everything's correct, you can actually try this if you followed along. Just select the handle, and you click it, and if you drag it, you can see that the assembly moves by itself, all connected. And with the limits, you can see I can't drag it down further. Right? So this lever part, the pulling back action, is now fully assembled in terms of joints. Okay? But as you can see, the only problem with this is this little assembly here isn't actually connected. And what I'll do is I'll just revert position. And there's two ways you can do this. The first one is to go in and animate every single thing that moves. In this case, you can see here, this is just a bolt with a little plunger plastic thing in the bottom. And there's two nuts that fasten the things together, as well as a little clamp thing here that just goes along the grooves. In this case, I don't want to animate or put joints on every single little thing. So instead, what I'll do is I'll just combine all of these into a single assembly. Right? And we can do that by going to Assemble. And instead of new joint or as-built joint, we'll select rigid group. And it sounds exactly as what it is. It's essentially a group of components that are going to be rigid. So think of it like combining, but without actually merging the solids together. So in this case, we'll just select all the parts here. So there's the screw. If you're not sure, you can always scroll down and see here all these parts. There's 1, 2, 3, 4, 5, 6 parts in total. Just make sure you selected all of them. I'm gonna hit OK. And now if you can see, if I were to move this, you can see I move it as a single part instead of the individual parts, right? If I go back, so before I've done my group widget, you can see I can only move the individual component. If I do my group, you can see now it moves as a whole. So this just simplifies things for me for the next step. And now lastly, what we want to do is just add this final joint that lets it slide in and out of this rail here, like it's intended to. We had an issue where we couldn't get this component to slide, and I figured out what the issue is. Like the idiot I am, what you're supposed to do, or what I did, actually I'll just show what I did, is I selected the entire group, like so. But I'm not. What I need to do, and this is why I got a bit confused, because if you select just this part, the part that actually slides on this rail, you select the lever, and then you select the slide, you see how this moves, right? And the rest don't move. This might be a bit confusing, but that's actually okay. I'll just set the minimums and maximums here just while I'm here. I believe the minimum is -50. It was a bit weird that way. Yep, okay. So now if you preview, you can see it goes up to where I want it to go. Hit OK. And now, if I click and drag, because it's a rigid group, everything will move along with it, like so. And now if I pull this up, you can see how this whole thing moves. Now, if you haven't noticed, I went from here to there because I moved it up. How I get this to stay at the tip, I haven't a clue, honestly. If you know it, then go for it. Play around. Again, I don't actually use a lot of joints in my work, so this won't really be very useful, I think, for most of you. Again, there are plenty of resources online, just look into that. And actually what I want to do now is I'll go back to this one, sorry, is I'll want to show you how to do, I think one of the most common questions is, how do I do a joint for a screw and a nut, or nut and a bolt? So in this case, what we want to do is we'll use this screw here as an example, okay? And what we'll do is we'll again build as-built joint, but this time instead of rigid revolute slider, we'll select cylindrical, okay? And with cylindrical, we're going to select the nut, and then we'll select the screw. And for the snap, what we want to do is select again the center of the axis. Think of it like the revolution, except it's going to be sliding and rotating at the same time. So in this case, I'll just select the top of this screw. You can always select somewhere else. And now you can see it's got that motion, but it's not quite correct. So what I'll do is I'll just add I'll adjust the limits. And here you see we have two options, because if you think about it, a cylinder or cylindrical joint is really just a rotating motion as well as a sliding motion simultaneously. So we'll set the rotate to 0 and 0, that's fine. I'm not going to put any limits. But for the slider, I want it to come up to just above the screw and not to go below this screw. So in this case, what I'll do is I'll set the minimum and maximums. And I'll set my max, I know this to be 40. Again, you can go and play with this if you want. But here, this is kind of what I want. That's okay. I'll preview this really quick. And it's not going to turn because I've only got this slider shown. If we hit OK, and now if we try to move this, screw. Oh yeah. Well, let's just one more thing you can do. Actually, I want to show you later. But if you try to move this here, you can see it's moving the whole screw. That's because what you need to do is you need to actually go to the screw component, which is in here. It's called the large bonded bolt. I think it's, yeah, large bonded bolt. And we'll right click on the component, and up here where it says ground, we'll select ground, and it sounds exactly what it is, ground. It grounds the part. So it's not quite a rigid, but it's like rigid, except you're not welding anything to it. And now you can see we can move our thing. But as you can see, this is not moving the way we want a nut to move, right? So what we next need to do is we need to then go to assemble. I'll revert first. We go to assemble. We're going to go to motion link. And that just sounds exactly what it is. It's a motion. You're linking two different joint motions, right? In this case, what we're going to do is we're going to select the cylindrical joint here, right? And in this case, we're going to say link with the same joint. So now we have our slide and we have our rotate, right? And our 360 angle is correct. Now, what's the distance? The distance isn't how far it goes up or down, but it's actually the screw thread. Think of the distance as how far does this nut move in the Z direction, the slide direction, if I make a full 360-degree revolution. So in this case, the actual thread probably is 1, but just so it's a lot easier, I'm just going to put 5. It makes moving it a lot easier. You can leave it at 1 as well if you like. And now if we animate it, you can see it's a bit fast, but we'll stop here. We'll hit OK. And now when we select this screw, you can see how if I try to move it up, it's not letting me. See, it tries, but it stops. What you have to do is you have to go and spin it around like a real world screw, you see? And so now I have a screw joint. And you can use this for animations and whatever if you like. For me, it's just, this is how you would do a screw and bolt joint, essentially. That's about it. To be honest, I'm not sure why that didn't work. It's meant to be able to slide. One thing I do want you to know also is that if you ground the screw, well, this isn't joint, but if you try to with the slider joint enabled, you see that you can't actually move the lever, and that's because remember you grounded the screw, so it's just gonna stay there. Essentially, you kind of like welded a screw down to hold the lever down. So I don't know how you fix that. If you're trying to do animation, I would suggest you have 2 different copies. You can always have one where it's the screw animation going in and out, and then the second one where all these are combined and you can move the lever back. Okay? Okay, so now we are looking at this model. We've reverted it back to where we initially started in the activity. And what we're going to do is, instead of using as-built joints, we're going to be using regular joints. And I'll show you how that's more useful, especially if you're working with components from different designs within your data panel folders. So what we're going to do first, if you want to follow along, is just mess this all up. So we're going to take a few of these pieces, move this out of the way like so, and for the time being, let's not move this one, just to keep things simple. You could always move it, but I find we can always use this as our reference. So we know that this is going to stay put, essentially. So it's the same thing. We can just use a as-built joint. You just select our part, and again, we just select the origin, make sure it's rigid, hit OK. And now this part is rigid, you can't drag it apart. And again, we'll do the same steps, except now with these positioned away from where we want it to be, we can't use an as-built joint, we have to use joints. So using joints will help to position our parts where they're meant to go, as well as apply the joint motion that we want. So let's make it simple, and we'll first start with this lever arm here. It's called the bottom clamp. So we'll again select joint. Now it'll look a little bit different, don't worry. But for our first component, it's the same thing. We're going to select our bottom clamp. So we'll select it. One thing I need to mention is that when you are selecting the snap, you don't actually select the component, you select where you want it to snap to. So in this case, if you're looking at this, we want our component here, this part, to connect to this part here. And now what we can do is as you can see, we can't really get the edge. And what I mean by that is, if for instance, let's just say we were to select this edge here, and we tried to do the same thing on this edge, you can see it's positioning it, but now it's in the wrong location. And of course, you could always try to move it down. I find this can be quite, well, it's not really necessary, and you can see there's some intersections. So I'm going to hit cancel. And instead, what I'll do is I'll select the center point because it's a lot easier to rotate it around that axis. So again, select joint. And you might be wondering, how do I select this center thing? My mouse keeps, moving and I can't quite select it. Well, a simple way is to just select this edge here, hold Control, hold Control, and now if you move, you can see that you can actually select each of these points here. And if you go out, you see I can't select any other points. So it's just a useful way of locking in your selection. Now if I click here, you can see I've selected the middle, and automatically it's going to tell me which part of my component to snap to. In this case, we've selected the center of the cylinder. So we're going to go here. It's already here by default. Again, you can hold Control and select the points. I'm going to select the middle. And now you can see it's perfectly aligned, right? And in this case, this is a revolute. So we're going to go to motion over here. And instead of rigid, we'll select revolute. And you see now everything is the same. I'm going to hit OK. And just like that, we've already positioned one of our parts. And what we're going to do next is we're going to attach this part first. I think this is a bit easier. So again, I'm going to go to joints. And if you look at where this is connected, this little cylinder here actually goes in this hole there. So same thing, we can select the center, hover over our cylinder, hold Control, select the middle, and now you can see it does the same thing. It's already in a revolute, just to double check. That's okay. We'll hit OK. And now the last one, second last one we'll do is this lever here, which we're going to again use joint. And you can see this part here connects to this cylinder here, right? In this case, what we can do is again, you can see we have a middle cylinder, right? But we don't have a cylinder here. And if we try our trick, you can see there's no middle point. So what do we do in this case? Well, this is where our origin mode comes in handy. Right now we have simple, which just means to point essentially. But we can also have between two faces. So if we select between two faces, you can see now there's a plane option. So we're going to select the plane and then select the point in between those two planes. So the first plane will be here on the inside face. The second plane will be here on that side. And now you can see, if it shows up, yep, you can see there's that little icon there. And again, we can't grab it, not even if you're quick enough. So again, hold Control and select this. And now you have your middle point, see? And again, simply with our second component, we'll change the view angle, select that middle bit there. And just like that, you have a perfectly positioned component. Again, we'll go to motion. We know this one is the lever. There's a constraint. So again, I'm going to put minimum maximum. I believe this was 65. Double check. That looks good. We'll hit OK. And now if we try it, you'll see that it doesn't actually work. Why? Because we're still missing this component. Now, we could always use an as-built joint. In this case, I'm just going to try something. Actually, I'm going to capture position, select my joint. Again, remember, we can select the middle point here. Just rotate the view, select the point. But we need to go to this point now. And it's the same thing. We can always select our between two faces here. Select the... You don't have to select the inner one. You can select the middle, the outer. And you can see that still gives us the same middle point. Because, again, it's about the distance rather than the actual plane. So we'll go to the edge here, hold Control, select our middle point. Now it's revolute. That's fine. Hit OK. And, oops. Oh, yeah, okay, so that seems to have broken it. I'm not very sure why, to be very honest. I think in that case, but anyway, that's what I wanted to show you anyways, that you can always just put these components. I think the reason why this broke is because essentially we forced this to move backwards and this has broken whatever. No worries. I'll just undo my capture position here in my timeline. We'll delete this. We'll go back, and we can always just use the as-built joint. This is in the way. So as-built joint. I mean, you've done this before. We'll just select the first one, the second one, and this would be Revolut. We'll select the middle point, and this should work. Now, let's try. Yep, that works fine. So you can always use as-built joints and joints together. There's no reason you can't. And this one might be a little bit tricky, right? If we take a look, let's just look at the section analysis, and this is why section analysis can be quite useful. We're going to select the plane, anyone, doesn't matter, and we're going to take a little peek on the inside. So we can see that this shape here, the profile, zoom in a little bit, this actually fits quite nicely with our part, the complementary part. So if I hit cancel, you can see this actually goes just nice. Now, what happens if I go to joint? Now, what can I do? I can't really select in the middle so much. Well, I find it's a lot easier, and this is a bit ambiguous, by the way. I find it's a lot easier. We go between two faces. We'll again select, again, camera's a little bit wonky. Select that. Select the second plane. And now you can see our point there. We're just going to select that point. If you can see, I'll zoom in a little bit. There's a little point there. It's just the one. Select that point. You can always check, and you can see there's almost like a little opacity control feature. You can see it's right in the middle. If you go to the left, you can see it's right in the middle of that. So essentially, it's along this line where our arc begins, which is here, actually. So for our second component, what we can do is we can just go into the middle here, and it's going to default to Revolut because that's the last one we used, but instead I want to have it rigid. Hit OK, and now you can see our part looks fine, and if we move it, it's combined in the same rigid form. Now, how then? Let's just say, let's just create a group first. If you haven't done this yet, we did this in the previous activity, well, not the previous activity, but what we basically made a group. Sorry, it's here, widget group. We'll revert the position, and we'll just select all of these components again. We just want to make these this all one whole part. We'll hit OK. Now remove this. You can see it's all apart. I'm just going to move it away. Okay, so now with our part positioned away, what we're going to do is think, how can we actually position this where we want it to be? If we think about it, we know that the bottom face here, it's going to rest on this top face here. But if you see the size of this, we basically need it to be somewhere in the middle here. So let's try, right? We're going to select the joint. Just go here. Again, control, middle click. And what we'll do is we'll select this face here, but you can see there isn't actually a point that I can snap on, right? No matter, let's just try the two faces method. Select the two faces here. And if we try to snap, you can see, yes, there is a point there, but this is too close. My part here is going to be sticking out of the end a bit too far. So I want it somewhere here, but I can't put a point, as you can see. So what can we do then? Well, what we can do is we'll go into, this part is our bottom clamp. So we'll go into our component and we'll activate it here, like so. And what we'll do now is we'll actually create a sketch and create the point ourselves. We're going to revert the position. And what we'll do is, you can see somewhere around here, sometimes it might not be there. Actually, I think I shouldn't have reverted. Let's just go back. Yeah, so I'll capture the position to hold this here. And again, I'll make sure I'm selected, create sketch on the top plane. And yeah, okay, so it's somewhere around here, I remember. I'm just going to go and create a point. So I'll deliberately miss this line here. Anyway, there's no snap, as you can see. So let's just put it somewhere here. And what we're going to do now is constrain this such that it's actually in line with this axis line. And so instead of drawing a line and making it ourselves, especially if it's diagonal, right? Think about it. What we can do instead is use the vertical constraint. This is vertical anyways. So I'm going to select our point here, and then I'm going to select this point, which we know is in the middle, right? This is going to position our point exactly in the center here. So as you play around with constraints and get more proficient at it, this will definitely be a very useful tool for you. But we're happy with this now. We're going to finish the sketch. And now if we try the joint, make sure to go back to your component, your main parent component. So we'll activate that. We're going to go to joint, do the same thing, select the bottom face, hold control and click the middle. Now we're going to select our second component, which is the point here. And you can see it move. Don't worry if this isn't moving. You'll see later that it actually will move with it. So we're going to select the motion. As you saw previously, it's going up and down, which we don't want to, right? We want to move left and right. So we can always select the axis of movement here, which in this case would be Y, as you can see. And I'm just going to create some minimums and maximums as well. And I'll just put it around here. 60 is fine. We'll hit OK. And now you see everything's moved there. If we now try to slide it, so we click and drag, you can see it's moving exactly how I want. But what about the lever? Let's try. So if you pull back on the lever, you'll see, yep, everything works exactly how I want it to go. So that's how you can use as-built joints and joints to assemble your assemblies, essentially, your components. Don't forget that with joints, the main difference is that they are more useful for positioning and applying the joint motion to components that are either not positioned correctly because maybe you've inserted components from a different design file, whereas as-built joints are for components that are already positioned in the correct place. So play around, have fun, see what you can do with it. We'll move on to the next activity, which is rendering.